Hi, my name is Brett Fleming and I'm the Corporate Manager for SPI Inspections in Edmonton, Alberta, Canada. My team and I are at a 500,000 volt substation in the Edmonton area. FLIR has graciously provided their newest GS77 gas detection camera for beta testing and evaluation. The camera not only detects SF6 gas leaks and other gases, it also has forward-looking infrared imaging capabilities with all the bells and whistles, and it's able to capture full spectrum images with the integrated camera array and toggle between them. You can see a red laser which is illuminated beside the lens. This is the camera using its autofocus feature to determine the range of the subject and automatically focus, giving us the best possible image. This feature makes the camera virtually hands-free. We are going to be working in two different substations. The first is a 500,000 volt AC to 250,000 volt AC substation, and the second is a 500,000 volt AC to 500,000 volt DC inverter station. Both of these substations are ultra-high security facilities, and the utility has recently completed repairs on some of their SF6 breakers. They have invited us in to look at their repair work and determine if there's any remaining leaks and to evaluate the camera. Obviously, this is not a typical work environment. Maintaining limits of approach is critical. We were escorted in, we attended their safety briefing prior to work beginning, and we followed all of their safety protocols. These cameras allow us to work outside our limits of approach and keep our people safe. Prior to beginning the inspection, we first confirmed that we had all the correct settings on the camera and ensured that we were able to detect the gas. We conducted a bump test with a small canister of SF6 gas. We did discover that the gas detection should be done on a calm day, and the operator needs to be conscious of the background behind the leak. A small leak can be difficult to detect. We found it advantageous to mount the camera on a tripod, which helps with longer video timings and steadying the camera.
One of the valuable lessons we learned with the GS77 is when we're using the camera and we're in video mode and we want to take and record something over the long term, use a tripod, a good commercial tripod, use a monopole to hold it in place when you're standing up there and holding it in place. You get a really crisp, clear picture of what you're looking at, and it makes it much better video quality.
We had the station operator help us to facilitate the bump test. He is holding the SF6 canister on the tailgate in preparation to release the small amount of gas, and Elton Hunter is operating the camera. You can see as we do the test that the gas is very visible. You can see the SF6 gas escaping, and this is a good way to confirm that everything is set correctly and operating properly. This is the first time that we've had an opportunity to work with this particular camera. FLIR has done a great job. The camera is very user-friendly in the field, it is easy to read, and it's easy to understand the symbols on the screen, making it easy to navigate the menus. Although the camera has an auto-focusing feature, it has the additional functionality of a manually operated focusing ring that allows us to fine-tune the focus. This works well with the swiveling aperture. One of the advantages of having the camera equipped with the auto-focusing and movable aperture is that you can adjust the displays so that you are always looking straight at the screen, and in highlight environments you can adjust the screen for optimal visibility directed away from the sun. Here we are looking at a 250,000 volt AC breaker. This is one that the utility has previously worked on, and the operator wanted us to verify that it was not leaking. In our initial walkthrough, we were able to confirm that they still had a bit of a leak. However, it would be an easy fix on the next maintenance cycle. Prior to taking infrared imagery, we performed an IR test looking at body temperature, because we can confirm what those temperatures are. On the right-hand side of the screen there is a temperature scale indicating the range from the coldest to the hottest temperatures on the image. And in the top left corner we can see the actual temperature, which is measured at the crosshatch in the middle of my chest, at 23.2 degrees centigrade, and the hottest point is 32.4 degrees centigrade. From this we can confirm that the color palette settings on the camera are correct. If we import the images into FLIR's thermography software, additional features are available to us. The tool I will highlight is the Spot tool. This tool is available in the upper left corner of the screen, and it allows us to place an additional reference anywhere on the image. This reference indicates the temperature at any point on the screen. Notice where I place the spotting tool, the temperature is negative 2.3 degrees centigrade, and if I move the spotting tool over to my neck, the temperature on the right-hand side of the screen indicates a temperature of 27.1 degrees centigrade. This software gives us additional features like being able to toggle between infrared imagery and a visual spectrum image, and it includes other features such as overlays to improve clarity. These features are discussed in FLIR's Thermography Level 1 course, and it may be the subject of a future training. This is a picture of a 250,000 volt breaker. We are standing back 7 to 10 meters looking up at the breaker in full spectrum. Photographing each piece of equipment in full spectrum helps us to identify and reference the equipment when we are authoring reports, and it provides a historical reference photo for future reports. It helps in tracking the health of the equipment. FLIR's thermography software provides this functionality, saving the time required to take a photograph with another camera. When we take an infrared image of the equipment, it helps us to determine if the equipment is experiencing any unusual heating. Again, this helps in the reporting and provides a historical reference. It should be pointed out that great care must be taken on a sunny day not to aim the camera directly at the sun, as it could damage the camera, necessitating a very costly repair. Finally, looking at the equipment in gas detection mode, we are looking for SF6 leaks on this newly repaired breaker. Fortunately, this phase passed inspection. We were unable to find a leak. It is as important not to find a leak as it is to find a leak. In this case, we confirmed that the utility repair was successful. Later, we did detect a slight leak on an adjacent insulator. In addition to simply taking images and video, the GS77 records audio. This allows us to annotate the video in real time. If there's something of particular importance, it can be recorded live on the video, and those comments can later be extracted and referred to in the report. The available camera array allows us to take full spectrum, infrared, or gas detection pictures and video, and FLIR's thermal imaging software allows us to toggle between them. Here Rick was standing off to one side using the SI-124. He was able to pick up a bit of a color hotspot for corona. However, looking through the GS77, there was no infrared hotspot detected. We took notes on everything which aided in putting our report together. This is a video in gas detection mode, and when we play it, if you listen, you can hear us talking in the substation. It is extremely difficult to detect a small leak, and this rendering of the video makes it hard to see. We suspect there is a small leak here. This would warrant further inspection and a longer shooting time to know for sure.
Right, it looks right from where the connection and where it screws in. Right there.
Yeah. Point that a lot of times we won't pick up on it. And if it's starting to, it'll go real bad.
With the GS77 in gas detection mode, there was wind, and looking upwards towards the sky, the background of high cumulus clouds made it difficult for us to detect leaks. We were able to get some very slight leakage from the base of the breaker with some fine adjustments and stepping through the video frame by frame at 1/3 speed. We were able to record this for our customers. It is important to be cognizant of the background and the wind conditions. A clear sky and no wind would be ideal. Unfortunately, the weather was never quite right during the time of our evaluating this camera, but nonetheless, there was some success. It's clear that much like a radiologist looking at an X-ray, a picture is just a picture unless you know what you're looking for. Anyone can buy a camera, but it's the experience that's key in detecting these leaks. Here we were standing about 20 to 25 feet away. This was almost too close, but Elton Hunter detected the leak coming from the orifice where the bottom of the handle comes out. Now at regular speed, it's easier to see when you know what you are looking at.
Oh, hang on a second. Here's another one.
Okay. Right at the thing?
Right at the base.
Yeah.
Right at the base of that one.
So we'll have to change it.
Here we are looking at an infrared video. If we see a hot spot, we identify it and report it to the utility for future repairs. At this time, there was 110 megawatts on this line and the equipment was running cool. It is this utility's policy to document and observe equipment that registers a 30° centigrade differential between phases, or if the temperature of the equipment reaches 90° Celsius. The utility then works repairs into their maintenance cycle. Here our operator took a full spectrum photo of a weed against some rocks. He was busy switching between modes, and he shot this photo to ensure that the camera's settings were correct. Now you see the same weed in the infrared spectrum. The weed is registering 25.7° Celsius and the surrounding rocks are 3 degrees warmer at 28.7° Celsius. The plant was shaded by the breaker. He does this to ensure the camera is set correctly since he was switching between settings. It would be a shame if he spent the next hour taking shots that can't easily be repeated in the wrong camera mode. Here is a picture of Rick and Elton. Elton has the GS77 and Rick's got the SI-124. This is Transformer 1. It has approximately 110 megawatts on it at the time. The transmission voltage comes in at 240,000 volts and goes out at a voltage of 25,000 volts out to the area. We are looking for infrared hotspots and corona issues and documenting them for future reference. Rick has a good clear view of the transformer. He is looking for corona hotspots, and he is taking a good look up and down the cooling fins, the primary bushings, the secondary bushings, and the conservator tank. Elton is looking through the GS77 to see if there's anything infrared that stands out. This image is what the GS77 sees in full spectrum. This is a snapshot used for documentation. We are looking for obvious signs of discoloration and any other contaminants on the vessel from animals or insects. This is the exact shot with the GS77 in IR mode. We are looking for hotspots and heat inside the transformer. After looking at this image in the FLIR thermography software, we determined that Phase 1 was running at 48.1 degrees Celsius, Phase 2 at 48.8 degrees Celsius, and Phase 3 at 48 degrees Celsius. Although it appears hot, the transformer is operating within normal parameters. Since there is no temperature differential between the phases, there's no cause for alarm. This is a photo of 3 reactors. The one on the left is 30 years old and the 2 on the right were recently replaced. They seem to be in fine shape on a first look, and they seem to be operating normally. Looking at the same reactors in the infrared spectrum and analyzing the reactors through FLIR's thermography software, the 30-year-old reactor is operating at 63.1 degrees, and the newer reactors from left to right are operating at 77.1 and 79.1 degrees respectively. It is interesting that the older reactor is running cooler than the newer ones. We had the operator check the load on each reactor, and they were all loaded relatively equally. There is about a 20-degree differential between them. Not a cause for concern to be worried, but the operator will monitor them, and we will document the difference and compare this baseline image with future images to determine if a problem develops. Here you can see this is one of the newer reactors, and we got down, took a look at it, and we are trying to find any hotspots, any anomalies, anything that seems to be out of the norm. It seems to be working properly, and this coil seems to be operating within parameters. Here Elton Hunter was laying on the ground when this and the following 3 images were taken. Sometimes you have to get down and underneath and take a look at the equipment from different angles. You have to look at things from 2 or 3 different sides to make sure you can see everything. This is what Elton saw when he was laying down on the ground. He was looking up inside the reactor for hot spots or cold spots inside and anything unusual. This is a full spectrum picture from on the ground looking up. Once again, looking for anything unusual, any contaminants that might be on the outside, and documenting anything that we might see from that perspective. From the ground with the infrared camera, Elton adjusted the focus and took a really nice clear picture to document what he saw from underneath. Where the support bars come together, it is actually quite hot. That's a bit of a surprise. It is important to document the weather conditions each day at each site in order to compare apples to apples in the future, or at least to explain any differences. We were looking here at a small breaker, and on it you can see the breaker number 502. The image was taken in thermal MSX mode. This is where the camera partially overlays the thermal image with a visual image for clarity. The amount of blending is adjustable through FLIR's thermal imaging software, and you can switch between these modes. This breaker was out of service at the time, so we didn't anticipate seeing any heat. And when you can't see any heating at all, the equipment has been out of service for several hours. This is transformer 1. It is a step-down transformer stepping the voltage down from 250,000 volts to 72,000 volts. You can see the cooling fins, hot on top and cooler on the bottom, and the bushings, cooler on top and hotter on the bottom. This is where the oil actually circulates up inside the bushings and in the cooling fins. And you can see that oil circulation is working properly. Each bushing is about the same temperature, so the load is balanced. So it's not a real hot transformer. And you can see the conservator tank on the far side is cooler. The transformer wasn't working very hard. This is the same transformer in full spectrum, and you can see me standing there for scale. The bushings on the top of the transformer are about 55 feet to the top from the ground. Elton was trying to take a full spectrum picture for reference, and we were documenting what we were seeing in infrared and with the sonic camera. The hottest thing in this photo are the people. No hot spots here. This is another good reference photo, as we know the body temperature is around 35 degrees Celsius. We moved over to the other side of the substation. Now these are 250,000 volt SF6 breakers, and you can see the 3 fellows for scale at the bottom. We are using the GS77 here to take the picture in the next 2 photos. This is just nice for everybody to see the size and scale of these breakers. This again is the same set of breakers, but in full spectrum. We like to take full spectrum pictures of everything. You can see the grounds hanging down on the right hand side. They were doing a little bit of work at the time, and everything was open and grounded. We were looking for gas leaks with the GS77 on the bushings themselves. We moved to another substation just down the road. You can see the 3 large cutouts with a fair bit of load on them. These conductors are about 1033 ACSR in size, and they have 2 going into each switch. At this particular time there was about 100 megawatts going through here. Everything seems to be okay in full spectrum. This is the same structure but looking through the IR camera of the GS77, and you can see the left-hand cutout is quite hot as compared to the center and the right cutouts. This was a bit of a surprise to us. We weren't anticipating this particular cutout to be hot. It was around 90 degrees centigrade, so this is something that was set for adjustment of the jaws the next time they were out of service. The utility should be a little bit concerned as there was a balanced load on the switches at this time. In this substation, the transformer is operating quite warm. The top of the cooling fins were quite hot. The bushings were hot. Everything else seemed to be running cool. As we walked out of the substation, we were asked to look at the air conditioning unit in the main building. The team lead was having a problem with the heating and air conditioning unit. They've been struggling with it for quite a while. He asked us to take a look at it. We opened it up and it was obvious that there was a fuse block on the bottom right and the top left that were running hot. He was very thankful. They'd been struggling with it for a while. It caused a couple of outages. The connections just needed to be taken out of service, cleaned, and put back together and tightened. They'd been over-torqued and it was causing heating issues. SPI Inspections would like to take the opportunity to thank FLIR for their generosity in providing us this equipment prior to their product release dates. This was an excellent opportunity for us to evaluate the equipment and showcase it to our customers. We would like to thank all the participants for attending. We hope that you found this session informative.